Welcome back to the Math and Physics Resource Center from Saginaw Valley State University. My name is Amanda, and today we're going to be looking at Math 261, Calculus 3, and we're going to be looking at integrating in terms of two variables over a rectangular region. Today we're going to look at the example of f of xy equals 3xy plus x squared, and that's going to be in the region of -2, 2, and 0, 3. So first let's draw this rectangular region. So this rectangular region is going from x -2 to x +2. And in the y direction, it's going from 0 to 3. So the rectangular region that we're going to be working within is going to be right in here. So now using this function, we're going to set up two integrals that we could possibly use. So the two integrals that we can possibly use is working in terms of the x region first. So that would be from -2 to 2 dx. And then following it up with the y. So it would be from 0 to 3 dy. Or we could do the reverse of that. We could do 0 to 3 dy, and then do -2 to 2 dx. So now let's transfer it over to. So when we solve both of these, we should end up with the same solution. So let's solve them out. So now we're going to solve out this first integral while we do x first. So when we take the antiderivative in terms of x, we're going to treat everything else like a constant. So that means we're going to take the antiderivative of 3xy, which is going to be 3 over 2 x squared, and the y just tags along because it's a constant. And then when we do x squared, it's going to be x cubed over 3. And that's going to be from -2 to 2. And the dy, don't forget about it, it is still there. So now let's solve for the middle integral. So 3 over 2 of 2 squared y. So we don't have anything to plug in for y, so we just keep y as y. 2 cubed over 3 minus 3 over 2, -2 squared y. And that'll be plus 2 cubed, -2 cubed over 3. And it is still within that 0 to 3 dy integral. So now, in a calculator, solve this out. It's going to come out to be 0y, so 0. Using a calculator, it comes out to be 0y minus, it comes out to be 0y plus 16 over 3. So 16 over 3 dy, and that's from 0 to 3. So 0 to 3, 16 over 3 dy, that's going to be 16 over 3y from 0 to 3, which comes out to just be 16 over 3 times 3 minus 0, which is 16. So now let's test the other integral. It should come out to be 16 as well. So let's try it out. So taking the antiderivative of 3xy plus x squared in terms of y is going to be 3 over 2 x, because it's just a constant in this case scenario, so it just tags along, times y squared. And that's going to be plus x squared y. And that's going to be integrated from 0 to 3. And the integral in terms of x does not go away. That's still there waiting for us when we're ready. So now we're going to solve out for the middle. So it's going to be 3 over 2. X sticks around because nothing's different about it. 3 squared plus x squared times 3 and that's going to be minus 0 because there's a y in both of these, so it comes out to be 0 from there. And don't forget that we still have that outer integral. So now use a calculator to solve this out. The new integral comes out to be 27 over 2x plus 3x squared. And that's going to be dx. So now one last integral we're going to take, and that's going to be 27 over 4x squared plus x cubed. And that's going to be integrated from negative 2 to 2. So now let's plug them in. So 27 over 4 times 2 squared, and that's going to be plus 2 cubed minus 27 over 4 negative 2 squared plus negative 2 cubed. And that comes out to be 16, which checks out. Either method works. I just wanted to show both. Thank you for visiting the Online Math and Physics Resource Center from Saginaw Valley State University.